the volume on. All right, so over your do now, you're supposed to go through and tell me if it was just a relation, a function, or one-to-one, okay? If it's just a relation, remember that means that the x's repeat, right? The x values repeat. If it's a function, then it means the x values do not repeat. And if it's one-to-one, that means that your x values and your y values do not repeat, okay? So on number one, my friends, what did we get? One-to-one, x's and y's both do not repeat. It's a function. No repeating x's. My y's repeat, but there are no repeating x's, right? All right, number two is pretty easy. Number two is a linear equation. In a linear equation, no x's and no y's repeat. So it's a one-to-one. The x's repeat. All right, on number three, what'd you get? Why is it a relation? Because the x's repeat. An R for you. Number four, one-to-one. Number five. So it's two graphs. You have f of x, and you're looking at the inverse. Is the inverse do any of the x's? So does it pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. That means it is one-to-one. No repeating x's, no repeating y. And six, if I was to graph the positive and the negative, this would make this just a relation. So that's what it should look like. Okay, so again, a function, no repeating domain values. One-to-one function means no repeating domain values and no repeating range values. And relation means that you have repeating domain values. Yeah. All right, today is a notes day. We have notes over functions with domain restrictions. Dun, 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 dun. Okay, so functions with domain restrictions. Here we go. Up until this point, we have learned that most functions are all real numbers. They go from negative infinity to positive infinity, right? On the domain. However, some functions are not defined for all real numbers and thus are evaluated over a restricted domain, okay? So when we're evaluating over a restricted domain, we have to do a little extra work. So the first one we're going to analyze is the square root function. And the square root function, the domain is restricted because we cannot take the square root of a negative number, right? The square root of -1 doesn't exist because a negative times a negative makes a positive. So therefore, it doesn't exist. So what this ends up looking like is whatever is underneath the square root, we have to set it greater than or equal to 0 and evaluate. And that's why the domain of our parent function, so our parent function, square root, at the top on the side, looks like this. This is our square root function, right? It starts at 0 and goes on to infinity. That's why when we wrote the domain here, we wrote from 0 to infinity, right? The range here is from 0 to infinity. Okay, and so we're going to use this and keep this in mind as we navigate through the rest. Got it? Here we go. Diving in. So the first function we have, what are the domain and range of g of x equals the square root of 2x minus 4? What is the inverse of g in its domain and range? Is g inverse a function? Explain. All right, so we know that g of x equals the square root of 2x minus 4. Okay, the first thing we're going to do is, because this is a square root, is we're going to find its restriction. So finding its restriction means I'm going to take whatever is underneath the square root and set it greater than or equal to 0. So I have 2x minus 4 is greater than or equal to 0. And I'm going to find that restriction by isolating the x. So what would I need to do to get x by itself? Add 4. What I do to one side, I do to the other. So that gives me 2x is greater than or equal to 4. And then divide by 2. So this lets me know that x is greater than or equal to 2. This is my domain restriction. X has to be greater than or equal to 2. So that means for this function, if I was to look at it graphically, it's saying that this value, instead of starting at 0, it starts at 2 and goes that way. Because x has to be greater than or equal to 2. Does that make sense? So I have to start at 2 and then go on. So my domain, we're going to write our domain two ways. It's from 2 to infinity, correct? That's our interval notation. In set notation, we have our, that's an ugly brace. Oh my gosh. Just ugly. I don't know what that one was. Let's try that again. That's better. Okay, so x such that x is all real numbers, but x is greater than or equal to 2. That one got questionable too. Oh man. The pen and I are doing some strange things. That's going to get y'all. Okay, now our range. When we look at our little graph we drew, did our range change? We're still starting where? What's 0? So we're still starting at 0, going to infinity. So our range is y such that y is all real numbers, but y is greater than or equal to 0. Okay, so this is the original function. It said it wants us to find the domain and range of the original. Did we do that? Yes. Now we're going to find the domain and range of the inverse. Well, and find the inverse. So we're going to find the inverse. So if I'm looking for the inverse, what do we do to find the inverse? What do I do first? So to find the inverse, I have to switch my variables around. There's an R in inverse, isn't there? Yeah, it's there. So I'm working with now x equals the square root of 2y minus 4. Okay, so what do I do to find my inverse? Square. What do I do to one side, I do to the other. So we now have x squared equals 2y minus 4. So I now need to isolate the y. So what do I do to isolate the y? Add 4, and I'm left with x squared plus 4 equals 2y. Perfect, divide by 2. And I'm left with x squared plus 2 equals y. So therefore, my inverse is x squared plus 2. Are we good with that? That's why we have to learn how to find inverses first. Okay, this is the easiest part here. Now that you have your inverse, your domain and your range come from your original. Okay, so the domain and range are going to come from the original. Remember, your inverse is saying that you're taking this and it's being reflected over the y equals x line. So its graph is doing a little bit different. It's starting here and it's going to reflect, right? So we're describing that, and because our x and y switch place, that means our domain and range. So what was the range of my original is now the domain of my inverse. But y is greater than or equal to 0. What was the domain of my original is now the range of my original. Oh, I still wrote y. Ding dong. Guys, what am I doing? And you just let me write it? That's cool. Me too. Erasable pen. No. I said they switched places. I meant it. And bam, you're done. You found the inverse, and you switch the domain and range, and that's the domain and range of your inverse. What are your questions? What did I write? You are seeing things. I don't know what you're talking about. There has always been a 2 there. See? You see it? Did I forget the 2? Dang it. Y'all are just waiting until I'm at the end to tell me I'm dropping the ball on things. Yeah, that goes there. This is going to be a great recording. I forgot the little 2 with the divided by 2 here. Lo siento, I'm human, running on 4 hours of sleep. And no caffeine this morning.
Wait, what you do?
I forgot the little 2, Celeste. The x squared divided by 2, right here.
Oh yeah.
You see it? My bad, my bad. Jesus. I was upgrading late work, y'all, to 2 in the morning. It's great. All right. Are we ready to do another one? This time, you guys are going to tell me what to do, and I'm just going to do it. Okay? So.
Is this one that we did first one?
Yes, but you're telling me the steps. I'm just going to do what you tell me to do.
Oh, all right.
All right. What do I do first to find the domain in range of the original? What did we do first? Restriction.
I was just going to say that.
I believe you. And how do I find the restriction?
You add the 2.
I'm going to add the 2, but before I have to do x minus 2 is greater than or equal to 0. And now, like Celeste said, add the 2. So we know that x is greater than or equal to 2. Cool? Still with me? Okay. I'm only gonna write, I'm gonna write the whole thing. You don't have to if you're comfortable. I just wanna make sure you're comfortable seeing them in both formats. Does that make sense? So if you understand what you're doing, then no. So for the domain and interval notation, I'm starting at, that's not a 2. Based on our restriction, I'm starting where? I'm starting at 2, and I'm gonna continue to infinity. So that's my interval. And set, it's x such that x is all real numbers, but x is greater than or equal to 2. One day I'm going to be a master of braces. Probably not. All right. Oh, no. Math braces. My range is unchanged. So the range of my parent function is still the range here. And the range of my parent function is from 0 to infinity. So y such that y is all real numbers, but y is greater than or equal to 0. Y'all were. I don't know why I'm talking. The one that says I do, you're doing 100% by yourself. I'm saying nothing. All right, how do I find the inverse? Switch the variables. is what I was instructed to do. So we now have x equals the square root of y minus 2. What is my next step? Square the both sides. The 2 sets it free. So we have x squared equals y minus dose. Add 2. Thank you. And that gives us x squared plus 2. That's not a 2. Why can I make 2's today? I want to turn everything else into a 2. Equals y. So therefore my inverse is x squared plus 2. Did we forget any numbers or variables? We're good. All right. And
Where'd you get 2 from?
how do we get 2?
Yeah, where'd you get 2 from?
Right here, where it says y minus 2. We added 2 to the other side
Mm-hmm.
because it was y minus 2 underneath when we did the.
Oh, okay.
All right, how do I find the domain and range? Just switch them, right? So the range here is now my domain. Is it okay if I just write 0 to infinity? Okay, I'll write it all out. X such that x is all real numbers, but x is greater than or equal to 0. Yeah, you're trying to trick me. And the range. Exactly. Just like we switch the x and y, we switch the domain and the range. So now my range is. Ha, welcome to my world. Those little simple mistakes, I tell you. They get you every time. 2. Bam, I wrote it. Oh, is it a function? Well, yeah. We have no repeating x's and no repeating y's. Yes. Because it's a quadratic with a restriction. It's a quadratic, the x squared. They're going to all be functions. Surprise. All right. Here you go. Mum's the word. Let me know if you need help. So, first thing you should have done is found your restriction. So when you found your restriction, that means you're taking whatever's underneath the square root and you're setting it greater than or equal to 0. You should have subtracted 2, and you got 3x is greater than or equal to -2. Divide by 3, and you should have gotten x is greater than or equal to -2/3. Yes? All right, so therefore, your domain starts at -2/3 and goes to infinity. Or if you were fancy and wrote your whole math sentence, oh, look at that. But there's your whole math sentence. And your range is unchanged. So it's from 0 to infinity, ... Okay? Then on our inverse side, we switch. So to find the inverse, we switch x and y. So we have x equals the square root of 3y plus 2. You squared both sides. You get x squared equals 3y plus 2. Subtract 2. X squared minus 2 equals 3y. Then you divided everything by 3. So your inverse equals x squared minus 2 divided by 3. In math, our goal is to use the minimum amount of characters. So if I can combine the denominators, I'm going to combine the denominator. All right, so my range is now my domain, 0 to infinity, x such that x is all real numbers, but x is greater than or equal to 0. And my domain now is my range. And my range is from -2/3 to infinity, ... How do we do? Doable? Yeah, yeah. You did. This is what you do. Yep. You're starting to see some patterns? Patterns in math? What? All right, our last restrictions of the day come from f of x equals 1x, which is our rational function, okay? Now, the reason why there's a restriction is the denominator cannot equal 0. The denominator cannot equal 0. Makes sense? There's no problem where the divisor is 0 and you're going to get an answer. So this one would be x cannot equal 0. And that's because if you think back to our function, remember that this function has asymptotes, right? It has a horizontal asymptote and it has a vertical asymptote. So we have a horizontal. So we have a horizontal asymptote at y equals 0. And we have a vertical asymptote at x equals 0. So our graph ends up looking like this, right? Do y'all remember this from our parent function notes? Really? Oh, I was like, what? Okay, and so the domain of this parent function, we have it where the domain is, we wrote it in two ways, in set notation and interval notation. So in interval notation, remember it's the one with the u. So we wrote the domain and the range are from -infinity to 0, union 0 to infinity. And that union lets us know that there are asymptotes. There's an asymptote on my graph. Okay, all of this is on our notes for our parent function, right? Not stealing it, not making it up, it's all there. Okay, so using our knowledge and what's happening here, we're going to identify restrictions and write how they affect the domain. So our first one, we have what are the domain and range of g of x, and what is the inverse of g, and its domain and range is the inverse of function. Okay, so we have g of x equals 1 over 2x plus 1. So we have 1 over 2x plus 1. The first thing we're going to do is find our restriction. And then we're going to take whatever is in the denominator, which is 2x plus 1, and set it not equal to 0. So I got to get x by itself. So what am I doing? Subtracting 1, and I'm left with 2x cannot equal -1. And then I'm dividing by 2. So x cannot equal -1/2. That's my domain restriction. So when I write my, right here where it says 2x plus 1, to get x by itself, we subtract 1. What I do to one side, I do to the, You're welcome. So then my domain and range are extremely longly written thanks to interval notation. So in interval notation, I'm going from 0, that's in -infinity, look how I fixed that, to -1/2, union -1/2 to positive infinity. In set notation, I'm not going to write both of these continuously because it gets ridiculous. X such that x is all real numbers, but x cannot equal -1/2. I had to squeeze it in there. It is. It's so long. Don't judge how I feel about my writing. And my range is unchanged. So it's from -infinity to 0, union 0 to infinity. Or y such that y is less than, or y is all real numbers, and y cannot equal 0. So that's my domain and my range. I should make these boxes bigger. On the inverse, I'm going to solve for the inverse. Okay. Yesterday we had was it yesterday? The day before we had a rational whose inverse was itself. This isn't the case here. Okay. You've been warned. So we have to switch x equals 1 over 2y plus 1. Okay, on Wednesday we talked about in order to get a variable out of the denominator, you have to multiply both sides by that variable. So I have to multiply both sides by 2y plus 1. They are an item. They are together. They are a family, and we do not split them up. Okay? So they travel together. So now we have 2y plus 1 times x equals 1. Instead of times x, what am I going to do? Divide x. I told you I didn't make this box big enough. So I have 2y plus 1 equals 1 divided by x. What's next? Minus 1, done. What's next? Divide by 2. Since this is already set up for division, I literally just got to sneak the 2 in with it. Divide by 2. Y is all by itself, so therefore my inverse equals 1 over 2x minus 1/2. Could you condense it down to one fraction? Yes, but is it necessary? No, don't do it. Divided by 2? 2? Just for future, if you just join the Zoom, you'll see this on your computer. Huh? But if you can't see the screen, it's the same screen. That's what I'm saying. It's us talking, and you'll see the screen. Yeah. I have a couple people that do it in my other class because they don't wear glasses, but they need to. But they probably don't want to mess up their lashes, you know? I figured it out. All right, so again, our range and domain are going to do what? Switch. So what used to be my range is now my domain. Which way do I want to write it? I don't know. I'll write it. Yeah, and pretty much at this point, you're like, draw the arrow, right? What was my domain is now my range. I'm glad you've caught on to the situation. I'll switch it up on you right here, though. Y, such that y is all of them. I'll give you a little taste of both. Okay? So then we have one more to do together, and then the other one you're going to do by yourself, and we're going to check on Monday. Got it? You have no homework or anything. Just that one I want you to try on your own, and then the answer will be on the board when you come in on Monday. Is that cool? All right, so this one we'll kill it together. All right, how do I find my restriction? X minus 3 does not equal 0. So therefore, what do? Add 3. X does not equal 3. So therefore, my domain is, because you can't have a 0 in the denominator, I'll write it that way, okay? And my range is unchanged. Okay? So then I have to find my inverse. So finding my inverse means that I'm switching the variables. So we have x equals 1 over y minus 3. Again, y minus 3 is a family. Do we split up families around here? No. So I'm going to multiply by y minus 3. And what I do to one side, I do to the other. Bam. So we have y minus 3 times x equals 1. It's times x, so the opposite of multiplying by x is to divide. So we have y minus 3 equals 1 over x. What do I need to do to get y by itself? Add 3. Now y is lonely, like it wants to be. That is not an x. No! I tried to outlast the sound. Oh. Where are we at? 1x plus 3. So that is our inverse. And what happens to our domain and range? They switch. The y just became its inverse. Remember when we were solving the inverse? So my range is now my domain. And my domain is now my range. And what is your challenge? Try to do the other one on your own. Okay, so you're going to do this one. You do example on your own. Have a great weekend. Make good choices.